guys, hope you're doing fine, enjoying my videos. And as you can see here, I have a set of 6 hard geometry questions, the hardest ever questions which I made. And as you can see here, this is the first question. And all these questions are actually graphed on a graphing calculator. So unless you think some statement is missing, well, all the questions are correct otherwise. And also, don't just, put the answer by measuring with a ruler or something. Do write the solution in the comments in case you've solved it. So coming to our first question, we have a trapezoid, and I can say it's isosceles because every trapezoid which is inscribed in a circle is isosceles. And this is an orange circle, as you can see here, the circumcircle, and its center is marked with orange O, and this is the incircle, and the incircle touches all 4 sides, which makes the quadrilateral tangential, and it's a green circle with its center marked in green also. And then we have the intersection of the perpendiculars from C to AD and D to BC. So they intersect at M, and just assume that AB is less than CD so that you have a single correct answer. And given that this condition follows, find the ratio of AB to CD. And let me give you a hint. The answer to this question is rational. And then comes this question. So this might be the easiest of these 6 questions, but it has a very interesting and beautiful solution. So we have a circle over here, and then there are 2 chords over here which are parallel, and then there are 2 other chords here which are parallel also, and then they intersect forming a parallelogram, and then the area of that parallelogram is 12 root 3, and this angle is 60 degrees, and the length of this part is 8, this part is 6, this part is 4, this part is 9. And all you have to do is find the length of the radius of the circle and the length of these 4 black segments. So that's your second question. And then comes to the third question, which has a triangle ABC, and then we have a point such that the perpendiculars from this point to AB and to AC are both equal to 1, and then the length of the sides of the triangle are 13, 14, and 15 respectively. So you have to find the product of the areas of these 4 quadrilaterals. This one, and this one. You have to find the product, and this is also rational, just so you know. And the answer to this question, the second question, is irrational, so harder to guess. And then coming to the fourth question, well, the answer is clearly irrational, and it looks very confusing and complicating, but let me make it look simpler. So there are 2 circles intersecting such that the centers are on either side of the common chord, and then we have lines drawn parallel to the common chord, tangent to each circle, and then they intersect each circle at 2 different points, and that forms an isosceles trapezoid by symmetry, and these angles are 60 degrees according to the question. And then you have the areas of these 2 triangles. So the ratio of the areas of these 2 triangles is fractional part of root 5. That's what these brackets imply. And then you have to find the ratio of the area of this blue trapezium and the red trapezium, or the trapezoid. And these trapezoids are formed by drawing lines passing through each intersection point and parallel to these equal sides of the isosceles trapezoid. So that's where they intersect the circle. Then comes our fifth question. This is also a very easy question, well, easier than the second one, because you're given 4 line segments, and the first thing you have to notice is make sure that the power of a point is satisfied. So the power of a point basically states that for a point inside the circle, you basically have this length into this length is equal to this length into this length. Basically, 2 into 6 is equal to 4 into 3, which holds true in this case. So the question is valid. And this is a bicentric quadrilateral, which means that it is both tangential and cyclic. So you basically have to find the in radius of that. So that's your fifth question. And coming to the sixth and the last question. This is very interesting and also has a very interesting shortcut, a beautiful solution, I would say. So you have an obtuse triangle ABC, and then you have a random circle. No, you have no idea about anything regarding the circle except that it intersects side BC and the length of this chord is 11, intersects AB such that this chord length is 4, and intersects AC such that this chord length is 1. So these are not the arc lengths but the chord lengths. Basically the chords which are enclosed by the intersection points of the circle with each side. And the area of this triangle, as you can see, is 14 root 3. All you have to do is find the radius of the circle. And also, the tangents from each point to the circle are equal. That's what makes this question complete. So, have fun solving these 6 questions. Do post your answers in the comments. And I'd like to see you next time. Thank you so much.